Alright, so in this video, I'm going to be teaching you guys how to solve a tetration equation. So most of you watching this video probably don't even know what tetration means. So before I actually start off with an equation, I'm going to start by giving you guys an understanding of what tetration is in math. So let's say we have 3 tetration 2. So with a normal exponent problem, let's say 3 squared, this is going to equal 3 times 3, right? So whatever number the exponent is, the base is going to multiply it by itself that many times. Now for tetration, instead of 3 multiplying by itself 2 times, it's going to take the power of itself that many times. So 3 tetration 2 is going to be 3 to the power of 3. And let's say 3 tetration 3, this is going to be 3 to the power of 3 to the power of 3. And so on and so forth. So that is basically what tetration is, and the main reason why many of you probably haven't heard of it before is because it's not used as much, because it's useless. 3 to the power of 3 to the power of 3, that's already such a big number, and this is a small tetration. Imagine something like 3 to the power of 100. That's going to be equal to 3 to the power of 3 to the power of 3 100 times, which is a very big number and which humans most likely won't need. So now I'm going to give you guys a tetration equation. So let's say we have the equation 3 tetration x tetration 2 is equal to 27. So I want to find the value of x. Now, this might seem a little challenging, but it's actually pretty straightforward. So before we actually go by and solve for x, what we're going to have to do is rewrite 27 as the base of 3, because this is just like a normal exponential equation. Let's say we have 3 to the power of x squared to the power of 27. To solve this, we're going to want to rewrite 27 in a base of 3. In this case, we're going to rewrite 27 as 3 to the power of 3. Now, 3 tetration of what is equal to 27? Well, this is basically asking 3 to the power of itself how many times is equal to 27. Well, 3 tetration 2 is equal to 3 to the power of 3, which is equal to 3 times 3 times 3, which is equal to 27, meaning 27 is the same thing as 3 tetration 2. Now that we have the same bases on both sides, just like exponents, or just like when we're solving exponential equations, we can ignore these and focus on the exponents, or in this case, tetrations. So now I'm left with x tetration 2 is equal to 2. And this is basically another way of saying x to the power of x is equal to 2, because x tetration 2 is x to the power of itself once. Now, to solve this, we no longer have to deal with any tetrations, just algebra. So when solving an exponential equation like this, I can use ln, also known as the natural log. So I get ln x to the power of x is equal to ln 2. And now if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this can equal b times ln a. In this case, I can move x to the front, so I get x times ln x is equal to ln of 2. Now from here, it gets a little more complicated to solve this, because I will be needing to use something known as the W-Lambert function, but more on that later. So x, what I'm going to do is rewrite this as e to the power of ln x. And if I have something in the form e to the power of ln of any number, it's just going to be equal to that number. So I have e to the power of ln x times ln x is equal to ln 2. And now I'm going to take the W Lambert function. And what the W Lambert function is if I take the W of something in the form p times e to the power of p, this is equal to p. So in this case, I'm taking the W of e to the power of ln x times ln x, and what I do on one side, I have to do the other side, so this is the same thing for my right-hand side as W of ln 2. And now from here, all I'm left with is ln x. So I'm left with ln x is equal to W of ln 2, and now from here I'm going to take e to the power of both sides, so I get e to the power of ln x is equal to e to the power of W of ln 2, and again the reason I'm doing this is to cancel out this ln, so e and ln cancel out, so I'm left with x is equal to e to the power of W of ln 2. And this is actually the most simplest form I can put this in. I can't simplify this any further. So this is going to be my final answer. And I know solving tetration equations are pretty challenging, especially when you have to do stuff like this using W Lambert function and logarithms.